Hello, Internet. It's Rob. Wanted to make a follow-up video to the parallax video I did on the Utah UFO. The discussion's been really great, and the big question has been the math, the distances, and how fast things can cover the distances. And it's great that we have the ability in this particular video to actually measure some of that and use Google Earth. And I want to show you how I did that. So when we're talking about bugs and birds and other craft that can travel distances and what we see in the video, we're all talking about the same thing. So I just want to take a minute here to just kind of wing it and walk through some of what I've done, do some math, and let you guys see what you think. Why don't we jump into Google Earth? So first of all, I think what we need to do is establish our location, right? So actually, before going into Google Earth, let me go to the video, and let's find where these guys started, and see if we can put that location into Google Earth. All right. Now I've already got a good proximity for where that is, as you might imagine. So let me try to match that up. And remember, all of this is information that I hope you guys will double check me on and cross check and do your own math and come back with some better information than what I've got. So this is where I think we are, and I'm going to show you why I think this is where we are, and I'm going to show you how I arrived at the locations for the drone. All right, so there's our distant mountain. As you can see, it's a little bit easier to see if I zoom in. We don't have the same field of view using Google Earth that we have through the camera's lens in the video. But let me switch back to the video now, and you can see there's our mountain, and here's where our guys are. Now, you've probably already seen some things, but I'm gonna jump through these kind of quick and show you some of the frames of reference I used, some landscape markers that I used to figure out where we are. I'm gonna just grab a pointer real quick. So you probably saw these trees here. These two trees are really great for our location. And if you look at the line that you would draw between this tree, and the truck, and how the truck intersects with the road, you can see that we've got a nice way to place that truck into our map. So before I go any further, let me just switch over there and let's see what we've got. Let's go truck location. And I'm going to zoom back in again. Keep in mind, I'm just kind of winging this, so sorry if it gets a little rough to watch. All right, there's our two trees. Remember, there's the mountain in the distance. And so you can see where those line between those trees intersects with the road, that's where our truck was, right? Hopefully you agree we're in the right spot. And we are just outside Beaver, Utah, so that much I know we have right. All right, so how did we figure out not only where the truck is, but also where the drone is? It just looks kind of just randomly placed back here off to the side. Well, what I used was the field of view of the drone, what it could see in the distance. So I looked at the far side of each of the sides of the frame to see what was what lined up. So let me just switch back and let's see what we have here. So if we're looking down the side of the frame over this side, you can see actually this guy right here is the utility pole that's way in the distance, and I'm going to show you that pole. Then there's a tree that's on the hillside, and those two things line up to where the drone is here. So we could draw a line. We don't know how far to draw that line, but at least comes to where the truck is. So let's see what happens if we just took a quick look at that before we go too much further. All right, so we move this guy over. I've already drawn a path just so that I had a frame of reference myself. There's the tree on the hillside, but where is the power lines? Let's see. I'm gonna zoom out a bit. We gotta figure out where this thing is. There it is. A little bit hard to see, but there's our power line, right? And it's throwing a big shadow. Utility pole. If it's not a utility pole, I'm not sure. Maybe it's a sign or something. But anyway, it can definitely be seen in the distance. It's kind of on the hilltop. And so we use the sign, the tree, and draw a line, and we get the approximate location off to the side of the road, and that's validated by the fact that we're not over the road. So you can pretty much see that that's where we are. You know, we've gone from here to here's where the drone is, right? So now we got to do the same on this side. And what do we have? Well, way back in the distance, you can see there's a mountains here, right? But there's not much else for us to work with. So this is kind of this is kind of an iffy one. But I think we can get pretty close, because if we take a little bit more look at this video and see what's just around the corner. Oh, there it is. So we've got a road here. And I'm going to see if I can go to where it clears up a bit. Nope. Does it clear up? No, well, we're going to have to just use that. So now I know that my frame doesn't come all the way to this road. It's closer to here, right? So I'm going to have to draw a line from the mountains in the distance near the road, but not directly at it, to my location. And that should give me a pretty close estimate. Is it going to be off by feet? I'm almost certain it would be. But it's going to still be a good approximation of where we are, because we have two other lines to draw to find that location. So let's see what we get on Google Earth. I'm going to come down here, and we can see there's our road and how it sweeps down. And let's see, there's our valley in the distance, so the lower trough and the ridge there. So we draw a line from that past the road to where it intersects, and I think that's a pretty good approximation of where that drone would be. Now, I just wanted to show you this technique and how I got this location for the drone, not because it has to be 100% accurate, but I use this distance to this truck and the real world, people, to measure them, to see how far things were, right? So this guy right here, I've got confirmation from Jimmy that Sam is actually these are the creators of the video here. He's actually 6 feet tall. So whenever I took a measurement of him with his head up, and how many pixels that is in frame, which I forget the exact number. I think it's 128. This guy is a good frame of reference for us. So at a certain distance, this is what 6 feet looks like. And guess what? We can figure out what that distance is. We can use Google Maps if you now believe where our location is, and we can take some measurements. So I'm going to just drop this in here. There's feet is the setting. So I'm going to click next to the truck and draw a line. Oops, did that opposite way. And just roughing it to where things are. Look at that. The truck is approximately, if we go to the back of the truck, there's 140 feet. And where would it be 130? So there's 130, right? Depending on how long you think the truck is and where my point falls, right? And then how about if we went just a little bit further, there's 160. So that would be out in front of the truck. That'd be the distance to the guys. So that's about what I used when I did my measurements to say the distance from the drone to the wing arm on the drone, which is this thing right here, right? I measured that with the actual drone measurements that are available online, and the center of the camera looking backwards. And I had some people question whether we're looking backwards or not, and you can tell that we're looking at the rear of the drone because this particular part of the drone is only available is only visible if you're looking backwards, right? And then this arm of the drone has a specific width, and so we can measure it. It's about 12 inches, and we know what this width is. And now this guy is 160 feet away, and we know what his height is. So now we can get a frame of reference, real-world distances, and use that to figure out what things look like. What I did in parallax video, of course, was I added in down here at the bottom. I don't have that handy, but you can take a look at it. What 1 inch looks like. So if this guy's 6 feet tall, you can imagine what 1 inch looks like. It's pretty much a speck. So at 160 feet, an inch is pretty hard to see, right? So let's keep going and see what else can we measure here. Now, the next thing that was important was the speed of the drone, right? So the drone actually moves to a landing spot on the road, right? And I have determined where that landing spot is by looking at the surroundings. And I don't have anything perfect in this case. I've got this little tree. I've got this tree that we're right next to with the truck, and then the road itself. These bushes are really hard to figure out, but we can kind of figure out where our placement is pretty close, enough to get a rough speed of the drone. If we look at Google Earth, you can see, let's get rid of the measurements for just a second. So there's our tree that we can see off to the right of the drone. There's the little guy in the distance. So from the drone's perspective, we would see this tree, and then off to our right, we'd see the bigger tree. And I think that's what we have. Yep, tree, bigger tree. Drone seems to be pointing a little bit to the left, pretty much towards this trough in the ridgeline up here. So let's take a look again at that. And there we are. There's the direction the drone is pointing. These guys are off to the side, right? So we're kind of heading towards these two trees right here. Two trees and then one off to the side. So hopefully you guys are having fun, because I know this could probably make you dizzy. All right, so we're finding our drone's location. Now imagine, if you will, you take this field of view that we've calculated back here. You can actually use the measurement tool to calculate this angle, and it's about 35 degrees. So we could just draw that 35 degrees again here, and we could line up where we are. I don't know that I actually got that accurate, so this measurement could be a little bit off, but it does fit with the specs of the drone that I've gotten before. So let's see, where the drone travels from here up to the hillside at a certain speed, and we need to know that speed because that speed factors into the speed of the object that is approaching, right? Let's see what it does here. Switch over, and we're watching it at half speed. And I'm gonna get rid of the little guy there. So this is at 50%, and let's watch the terrain. And part of the reason I want to kind of go slow and make sure you guys see this is I want everybody to agree where we are and what the distances are, so that you can use that for your measurements when you're calculating what you think it is and what's feasible and what isn't. Maybe there's some places where I haven't. There's our bug. I don't know if you saw that. There was one of the little bugs. Maybe there's some places where I've got the measurements just off enough that when you add up all of these variances, it can equal something a little bit different. So I'd like to see what you come up with. So here's the two trees, which is a landmark I want to find. There they are, right there. Little tree off to the right, and then one just up from that. And I think that's what we can see here. Let's switch over to the video again and see what we got. Tree, and then the little one off to the right. So that's perfect. So far the trees are doing us a favor and giving us some really great measurable landmarks. Now we're heading up to the ridge line, and you can see we're increasing in height. Be hard to guess for me what this is. I suppose you could probably measure it elevation-wise in Google Earth. I haven't done that, but you guys may enjoy doing that. But let's see if we can figure out what our target location is here and about when we start to lose things out of frame. And that's going to be how we figure out the approximate drone location. All right, so right up in here is when we start to see our object. It's tiny, tiny. I don't know if you can spot that, but I believe, if I'm not seeing this incorrectly, it's about right there right now. Let me just back up and see here. Yeah, that's it. All right, so the object is starting to come, and somewhere up in here is the 1 second mark. In other words, it takes about 1 second for it to get from there out of screen. So it should take 2 seconds if I play it now because I'm at 50%. Yep, that seemed about right. All right, so let me just back it up a second, and here we go. So where is this thing starting to see? What are we losing here? We've got this trees in the foreground. So I've got this clump of 3 trees here. There's one on the hilltop. Let me point with the arrow here. There's this guy on the hilltop. We got this guy on the hilltop, and I'll show you that they are on the hilltop in just a second. Of course, our utility pole in the distance. We got all kinds of great stuff to use. And then this clump of trees in the foreground. There's the one farthest to the right. So we're shooting right this way. And then this big tree here. So let's see if any of those things, I'm going to leave it right on that guy. See if any of these things line up. So let's go to this location. All right, we got our field of view again, right? And so we're marking what it is that we can see. And remember, the drone is at a certain height, and we're not sure what that is, so we don't know what's going to drop out of view based on the angle of the camera and how high the drone is. But you can see it's kind of close to the hilltop, so reasonably, this is our clump of trees right here. There's our 1, 2, 3, probably 4 trees. There's the one on the right. And switch back real quick. You can see that guy there, the one on the right. And then here's the clump of trees on the far right, which are near the right side of the frame. And this is where we're almost losing them out of frame, right? So this guy right here. And that's this guy right here. So that's just super because it gives us a nice way to line this up and see where the drone is. If I pull back, we should see utility pole. I don't know if you guys can see that guy, utility pole. And then we've got this guy on the hilltop, which is near the far right of the frame. And then we got the big tree in the foreground. Does that match what we're seeing? Utility pole. And we've got this tree, and we're off to the right of the tree, and then we got this guy in the foreground. And of course, the particular frame I've stopped on might judge when we see these things exit frame. See the change in the location of those things as we move forward. All right. So we're pretty close with the drone and what its location is. I hope that you guys would see that. We can look off to the left now and make a similar judgment. I would recommend looking at the hilltop here as one piece of it. We're just after it flattens out. And then we see these trees here. These are a little bit tougher to match up. I'm going to spend less time on this, but I can assure you it's pretty close. As you might know, I spent a little time on this. So there's our hilltop, right? We've got a line drawn from that hilltop. And I believe there might have been a tree up in here I used. Maybe it's these guys, I think, as the second point in order to get a triangulation. So approximate drone location in the air, looking this way, flying this way, believe it or not, flying this way, but looking slightly to the right. And now we can take measurements. So let's see if that's our drone speed. If that's our drone location, how far is it and how long did it take to get there? Well, the length of time that it took to get there is 40 seconds. You guys just watched it in about 80 seconds because I'm watching it at half speed, but I'm just going to show you from here. This whole distance is 40 seconds till it reaches the point where we start to see the thing come out of the hillside. So how fast does something have to be going to cover this distance? Let's figure out the distance in 40 seconds. All right, so I'm going to just click and draw a point and go to that location where it lifted off next to the road. And we've got, well, let's go with 1660. You ready for the math? Here we go. Here's our first one. And bear with me now. Don't roll your eyes yet. All right, let's keep this up. All right. So we've got 1660 is how many feet it went in 40 seconds, right? So I want to find out how many feet it went in 1 second. So I'm going to divide by 40, right? So how many feet did it go in 1 second? It went 41.5 feet in 1 second. Okay, still going. Let's see. If that's 1 second, then what's 60 seconds? Times 60. So that's how many feet it went in 1 minute. And now how many feet would it go in an hour, which is going to give us our miles per hour, if you bear with me. So let me say times 60 equals how many feet it would go in an hour. But how many miles per hour is that? Well, that's because kind of a crazy, unrelatable number. 5280 is how many feet are in a mile. So I'm going to divide that number by feet in a mile. 28 miles per hour. That perfectly matches the spec for the drone. The drone can travel at 28 miles per hour if it's not quite at top speed. So good number, and actually higher than I thought, because it doesn't look as if in most of the footage we watch is slowed down. It doesn't look as if the drone's actually traveling that fast. So 28 miles per hour. So that will have an impact on what we see. All right. So let's see. Keep that one in mind, and let's see if we can take some other measurements. This particular video is just for me to show you how I got what I did and how you could do the same thing. And I want to see the videos from you guys of what you come up with and what your math says, because this is how we arrive at conclusions and how we rule out possibilities. All right, let's see what we got next. Got some more distances to measure. First of all, let's confirm the big one, which is, where did this thing start? So let's look on the hillside over here, and I'm not gonna go for too accurate of a spot, but I've dropped a spot down where I think this thing originated. You guys can spend a little time on that if you want. I'm gonna zoom in. Here we go. It's a zoomed in spot. You see it. If you could possibly pick this thing up, it is right here, right? And I'm gonna just back this thing up, and you see how it turns up the mountainside? So right here, it turns and goes up. Oh, I lost it myself. It's a tough one. Let me see if I can actually zoom in a little bit more. And keep it in frame. And where did that guy go? There he is. Turns and goes up. So it's right here. And turns and goes up the mountainside. So it turns up. So what I did was I kind of said this thing probably originated somewhere on this particular, underneath this particular mound of the hillside. So somewhere up in here. That's what I've got, I believe. Let's see, what did I say? Yeah. All right, and that's probably a little bit far, actually. That's probably a little bit out of view for where we would have seen it. So I think it's actually down a little bit from that. But hopefully you guys can all agree that's about where it starts. But we're not measuring that as the originating spot. We tended to be measuring this thing from, oops, sorry, wrong thing. And this guy right here. We tended to be measuring this from, let's see. Put this in view. From what I would say is about right there. You can calculate the exact point when it's a second back there. It would take me a little bit to do that, since my well, I can do it. My video is at 50%, but I could still. But so there's a spot where I think it's about 1 second from leaving the frame. So let's flip over to Google Earth and just grab some approximation, right? There it is. Temporarily get this out of the way. Hopefully this isn't too terribly hard for you guys to watch. And Let's see here. You got to back up a good bit because we're talking quite a distance. If it's way back there. And so I know some of you may find that this exercise is total futility because you don't believe that that's where it originated. And that's okay. I'd like to see some other alternatives. But just for the sake of measuring, I'm not gonna worry about this being too accurate because we are talking miles here. But I wanted to get some roughs. No, there are some people who hadn't ever seen this measured out before. So I'm gonna switch to miles. Look, that's 2 miles when it exits the valley right there. It might have been 2.5 when it started. So that's 2.4. Let's see, there's 2.5 right there on the side. So I suppose that's up to you to figure out if you want to use kind of round it to 2.5. Why don't we just do 2 miles? Let's just do 2. Let's say from there to the drone. You can see I've used a helicopter. 2 miles. So it flies 2 miles in 1 second. Let's just see what that calculation would add up to. So 2 miles in 1 second, right? That's 2 miles. So what about in 60 seconds? How far would that go? So that's 120 miles in a minute. And then times 60 minutes is 7,200 miles per hour. And of course, when we did 2.5 miles, we got 9,000 miles per hour. Pretty ridiculous sounding speed when we think in terrestrial terms, I suppose. We don't really have a familiarity with things that can go that fast. So, it's all just fact-finding and speculation. Have we discovered some new phenomenon that we're learning about? Maybe. I don't know. All right, 7,000 miles per hour to get from there to here in 1 second. But let's go with some other measurements now that I think you guys tend to be more familiar with. And I want to focus on the bird analogy for a second. A lot of people have said it's a gyrfalcon or different types of falcon. I think the gyrfalcon actually has white plumage at a certain point, so it sometimes can look white because most of the birds and bugs that we see in these videos look dark. And of course, the object when it flies by, it definitely looks light colored, right? So we want to see, is that a bird? Is that a way that's a falcon? So it's not making a dive per se. It actually doesn't change elevation that much. If anything, let me move this guy. If anything, it's dropping in elevation as it comes down out of the canyon there. But it's not a dive, and then it flies past. So that's a lot of speed if it was coming from that far away, and if it's closer, then it's still not coming out of a dive. But it's also not apparent to me that there's any wings flapping. Maybe you guys see something I don't, but let's see. I'm going to just play that through a little bit slow. Yep, that looks to me like it's kind of cruising by with no movement. So let's look and see. What else do we have in this particular view? Come up here. We've got the utility pole, all right? So maybe this thing is actually flying from about the location of the utility pole, right? I'm going to actually zoom in a little and get that guy in frame. Let's see here. Where is that? There it is. So it's on the other ridge line. So maybe this is a bird that is on that second hillside, right? It's right above the hill, and it's just swooping down. So it's coming from about the location of the power line. I don't know if that's something you guys have thought might be possible. Let's see. What if that's a possibility? How fast would it have to be going? I think we're going to stick with the fact that it crosses out of frame in 1 second because that's what makes this so unique. So let's check out this utility pole here. All right, I'm going to clear that previous distance. And again, I realize I might be droning on here, so this is probably a long, boring video that not many people are going to watch, but hopefully the ones who can hang through it have gotten some good information. Okay, utility pole. Drawing the line here to our drone in Google Earth. 0.25 miles, right? Quarter of a mile. which if anybody wants to know the feet, I can't do that in my head. So there we go, about 1,300 feet. So 0.25 miles. All right, here comes our favorite thing, the math. We're going to do 0.25 miles in 1 second, right? And we want to see how many miles per hour. So we've got 0.25 miles in 1 second. So how many miles is that in 1 minute? So times 60 is 15 miles in a minute. And then times 60 again is 900 miles per hour. Well, that might have surprised some people, I think. 900 miles per hour. I'm going to just leave that up for a second. From the utility pole, doesn't look that far away. Let's just go at this again. The utility pole, I'm zoomed in, but that utility pole just doesn't seem that far. But look, we just looked at it. We just looked at the measurement. Let me actually switch back to a view that is more accurate because this is the original footage. There's the utility pole, right? There's our object. So going from the utility pole out of screen, out of frame in 1 second. And when I say out of frame, let me clarify because I'm trying to think of anything that might help get us all on the same page here. So when the object flies up and crosses past this point, it's passing the ridge line, it's passing the trees, it's going out of frame this way. That's why we know it has gone this distance. That's why the measuring to the drone, it works for us. It may not be exactly to the number of feet to the drone because it's not traveling to the drone. It's of course traveling out of frame, but it's still going this distance, and that's why it's relevant for us to measure that. So that's I think that's probably pretty surprising for some people. From the utility pole, which means from that ridge, right? Let me do this again because I want to make sure I clarify that it's coming from this direction. It's not coming from the utility pole. All right, so let's do that again. Let's do it again. It's coming from this direction, right? So it would have to be on the hilltop and come towards the drone. So, we still get, in fact, we might even get further depending on where I drop the anchor point. Still 0.25 miles. So our measurement is still pretty accurate. I want to say this again. From the utility pole to the drone requires 900 miles per hour. It doesn't make a difference what a bird at that distance looks like. The bird has to be really, really fast. Okay, so let's look at some other things because maybe that was just a waste of time because that was all misperception. And let's get down to some distances that make more sense for what a real object could do. Now, I showed in the parallax video why I think this isn't a bug, and I think I proved it. Now, it's important to know that, remember when we were looking at these guys, and they're, sorry, I gotta jump to the wrong place. These guys. This measurement is what is important because an inch on the frame where these guys are is, about the size of a pebble here. The little black dot there, if you can see right in front of the arrow, that's about an inch, the way I measured it. It's about a 2 by 2 pixel square, right? And an inch is actually, if you look at a ruler, a pretty fat bug. I don't know what kind of bug that would be. But this distance is 160 feet. So at 160 feet, that's how big a bug would be smaller than that, right? But about that size. So our dot is actually smaller than that, right? If it's closer, then that's going to get bigger. The closer it gets to the frame, remember as things get closer to the camera, they get bigger. Look at the drone itself, right? The drone is huge compared to the truck because it's closer. So the bug can't travel that distance from that far away past the drone. So it has to be far away in order to be tiny. That's my point, right? The bug has to be far away in order to be tiny. And and like the little speck on the ground here. But it has to fly so fast that it can actually pass out of frame and not far away like the butterfly did, right? Because that was small when it went out of frame. It has to actually grow in size and therefore get close to the drone. And we can measure, because we use this guy right here, we can measure how close it has to get because we know this size. This is 7/8 of an inch from here to here. That's the width of this arm. So a diameter, I should say, of this tube. So a bug is at least half of this size. And that's about the size of what passes out of frame, right? So this is why we know it went from at least this far back to the drone. And remember, my video says that it was, I think, 109 miles per hour. I did something wrong in my video. You guys write this down because this is the only time you'll probably hear me say this. So in the video, I did not incorporate the drone's forward speed. So that means the bug didn't have to be traveling 109 miles per hour. It had to be traveling 81 miles per hour. I didn't bring it up and I didn't make the correction because, and maybe I'll do an overlay or a caption or something, there are no 81 mile per hour bugs. Not even with the wind blowing. Maybe in a hurricane. The fastest bug can't do 81 miles per hour. So, I didn't think it was worth making such a change for. But maybe I will. Maybe, if I'm going to hold up the integrity of what I do. All right. So let's get back to the last measurement. So we've determined it can't be a bug. I'm going with that. So what else do we have in frame here? All right. We've got these trees that are much, much closer, and this hilltop, right? Hopefully you can see my mouse, right? There's the hilltop, there's the trees, here's where the drone starts, and there's what we see in the distance. So let's take a quick look at this guy. When it gets to the hilltop, we can see the, you can see the object here. You can see this tree in the foreground. I should say midfield area. All right. Well, this is pretty much the top of the hill, and we'll look again at Google Earth, and you can see that's the top of the hill. All right. So here's the little speck, right, that some people are calling a falcon. And we're going to assume that this is a falcon on the top of this hill. It has to be right above the top of this hill. And let me just rock it forwards and backwards a couple of times so that we see that that's a hilltop, right? And where the drone lands, there we go. All right. I think you guys get it. Right, so back here where it's at the 1 second mark, approximately, I realize I'm approximating that. I'm comfortable with how close I am. I've looked at this a lot, so I'm comfortable that's about the 1 second mark for when it flies off. That has to be a hawk right there. And it has to be the same distance as this tree. So let's take a look. There's our trees. I can hear you guys now. You're saying, "Oh, this is it. This is the deciding factor because it's a hawk that's a speck right about the distance of these trees." There we go. Measure. Let's see. Let's go with feet in this case because I think we're going to be a little closer. And there's our tree. Everybody should agree, right? I'm going to just drop it right on the tree. Go to the drone. What do we got here? 411 feet. We'll say 410. How about that? All right. And so 410 feet, right? If it's a hawk that's right above this tree, it travels 410 feet in a second. In fact, let me just push it out of frame over the other side. So we've gone out of frame here. What would that be? 360. I'm gonna give you guys a little bit further. I'm gonna make this really close because I feel like people want to see it be close. And oops, I lost my calculator. So there's 360 feet, right, in 1 second. And then times 60 gives us 21,600 feet in a minute. And then how many can it do? And there's how many feet if it was going for an hour. So let's divide that for the magic moment by 5280. So going from this tree out of frame, before it gets to the drone, but out of frame early, it would have to be traveling 245 miles per hour. But wait, you say, that's not true, because the drone is traveling 28 miles per hour. You're absolutely right. We cannot count that 28 miles per hour. I'm going to subtract that 28 miles per hour because that's how the math works. We can take away that 28 miles per hour. 217 miles per hour, therefore. If you believe that that is a hawk that is 360 feet away, otherwise approximately where this tree is, this tree, that's the one we measured, and that it flies out of frame right here, and I'll just play that. In 1 second, that was 2 seconds, by the way, then that animal is traveling 217 miles per hour without flapping and without an obvious dive. And from what I have researched, and I am no bird expert, there are no birds that do that. So I have arrived at the conclusion that it's not a bird, it's not a bug, and that it is something that is worth our investigation. It could still be CGI, right? Everybody is going to fall back to that now. Well, you've proven that it's not a bug. You have shown how it's not technically possible to be a bird unless there's some other thing that's not being considered. And so what is it? Well, it must be CGI. Well, this is where we have to pay attention to the source. And the source is talking. The source has provided the original file. The source has said they're going for more metadata if they can get it off of their equipment. The source has said they were there, they didn't see anything. They provided exact location, right? The time. And they're speaking about this. And that's something we should all appreciate. And it doesn't mean they're telling the truth. Maybe they have ulterior motives, and that's something that it's up to you to figure out. But I tend to move forward by first having faith in people. And I first believe people until they give me a reason not to. So that's what I'm doing here. I am actually looking at this, taking into consideration that the source said, this is real and I don't know what it is. And for me, it's pretty amazing. Thanks for hanging with me for so long during this video. I'll try to answer some questions about it. And we'll see you guys on the internet.